Newton's first law states that an object in motion will remain in a motion unless acted upon by an outside force. And what we mean by motion, or in motion, we mean with a constant velocity. So with a velocity, we'll say constant, we'll maintain that velocity unless acted upon by what we're going to say is a net force. The sigma here just means summation. So, and that's because we define net force as the sum, or rather the vector sum, of all the forces acting on an object. So what we're saying is, if let's say I have a glass of water and it's sitting on a table, the free body diagram might look something like this. Normal up, gravity down, and if these two, if their vector sum is 0, the cup should stay where it's at. It's at rest, so it will stay at rest. Now, let's say there's a cat in the house and it loves to knock things off the table. That would now impart a new force, so force of the paw on the cup. Sure, these two still balance, but now we have a net force. That cup, you know, it was at rest and now it's going to fall off the table. So this example here, we have an example of forces causing motion, but that's not what first law is stating. It's stating an object that is in motion or at rest will keep doing what it's doing, essentially. So here we just have a velocity that is constant. It just happens to be 0. In this instance, maybe we have a puck that is sliding on ice, so there's not a whole lot of friction going on, so it's moving, but the free body diagram would still look like this. The friction would be negligible, so we wouldn't draw it. So here we have a velocity that is not 0, but it's still in what we call equilibrium. That meaning, equilibrium meaning the net force, the vector sum of all the forces, is 0 newtons. So two objects in equilibrium. Here the paw caused it to move, but the puck here is already in motion. If we introduce a stick to the scenario, so a hockey stick, let me clean that up. So now we have the stick, and it's imparting some stopping force on the puck towards us. So force of stick. We have gone from some forward velocity to, well, maybe a slower velocity. Eventually maybe it stops, or perhaps it rebounds. So initial, and now we have some kind of different final here. In this case, we have a velocity that has changed, a motion that has changed. So what first law indicates to us is that net forces cause a change in motion. And if we pay attention to how quickly that change in motion occurs, so if we know the rate, we can figure out the acceleration. So first law is implying that net forces cause an acceleration. And we'll get to that in our next video.